briefly outline the structure of today's session. The speaker, which we have her here today, Claudia Sima, will give a presentation of approximately 40 minutes, followed up by 20 minutes more or less session for questions and answers. And there we will have an opportunity for a more informal discussion, let's say. So my colleague Salome will start the recording, and then we will start the session.
The recording has started.
Oh, sorry. Sorry, I didn't got the notification. So then I will stop sharing my screen. And officially there, everyone, welcome and thank you for joining us today. This is the second Library Science Talk of 2026. This is a part of series, as I already mentioned, organized by the Central Bibliothèque, Zurich, CERN, and ALIS, this Association of Information Librarians and Information Specialists. And we are delighted today to welcome Claudia Sima from the Swiss Institute of Bioinformatics, who will present on a session on opportunities of generative AI for knowledge and discovery and exploration. So without any further explanations, I will hand over the floor to you, Anna, and so please go ahead.
Thank you very much. Thank you for the introduction and for the invitation to present today. I will share my slides and start the presentation. So I'm very happy to be here. I co-lead the Knowledge Representation Unit at the Swiss Institute of Bioinformatics, and I will talk about some of the opportunities, also some of the limitations, and perhaps how we can combine both worlds for improving knowledge discovery using novel generative AI technologies, and with some examples from things that we are developing in the Knowledge Representation Unit. So the outline of today's talk, first of all, given the context, so because I'm coming from bioinformatics and today it is a library science talk, so what do bioinformatics and libraries have in common? I will try to go through some of the points that I think we share and we can learn together. I will talk about generative AI, both opportunities and limitations. Most of the points that I will mention are fairly high level, and I hope this is okay. But as mentioned, we will also have time for questions at the end, so we can go maybe a bit more in depth. And I will talk about opportunities for knowledge discovery and exploration and some of the services that we are developing, including Exposé GPT, which is a service that we have developed for semantic search in a particular use case across knowledge graphs, so cross-silo semantic search. So first, what do bioinformatics and libraries have in common? And I will talk particularly about the Swiss Institute of Bioinformatics. And to start with, repositories of knowledge. So the Swiss Institute of Bioinformatics has a long history and a mission of providing high quality curated knowledge bases in bioinformatics to the scientific community. And these are provided as public data and seen as a public common good. And I think with this, we share the same vision with libraries and other public digital repositories. So of course, these are very domain specific, but just to mention that some of the databases that you see here have become authoritative in their domains. For example, UniProt is the reference encyclopedia, if you will, for protein information. And other databases as well have become very prominent in their own fields. And these are either directly maintained or co-maintained by the Swiss Institute of Bioinformatics. Now, stemming from this goal, we, I think, also share common processes with libraries because we have to curate data, we have to publish data in a format that is easily accessible by either domain scientists or the general public, and we also have a mission to preserve and archive open data. And these are all because of a common goal, which is to enhance the value of open data and knowledge, and of a common commitment towards open science that I think we share across the participants here, and of course at the Swiss Institute of Bioinformatics as well. And more broadly, we are part of, obviously, the European landscape. So I will mention here also the European Open Science Cloud, which is a vision to provide a European data space for research by federating data, tools, and nodes in the end across the European space in order to provide researchers with access to these research innovations without borders across Europe. And the Swiss Institute of Bioinformatics is also involved in this, and I will mention a bit later some of the projects. But just to mention that perhaps you already know also CERN is one of the nodes that already exist in this federation. So all the nodes that you see here are essentially one of the node of the EOSC Federation, and Switzerland has also recently been approved to become an official node in the EOSC Federation. And I will talk about some of the opportunities that are used for data democratization in the European Open Science Cloud, in the Europe Open Science Cloud Data Commons project a little bit later in the talk. But first, about the opportunities and some of the limitations of generative AI. To start with the basics, and I'm sure by now everyone is familiar with this, a large language model is a deep learning model trained at a high level to predict the next word in a sentence. So always one word at a time based on a given corpus. If you have a corpus like nothing is impossible, even the word impossible says I'm possible, presuming you would give the prompt, so the prefix or the text that has to be continued, nothing is, the model is supposed to predict impossible. And this is very powerful because it's self-supervised learning, so you don't necessarily need to annotate text in any way. The model learns by itself, and it will learn to predict one word at a time. But it turns out that this is quite powerful, as you have probably seen, across a wide range of domains. And the end result, as we know it, is something like ChatGPT, where you can essentially ask anything. So you can ask the meaning of life, if you will, and it will tell you something. Or you can, of course, ask scientific questions and things relevant to your domain. And depending on the data that it was trained on, you will get a more or less relevant answer. This is based on the art of prompting, if you will, or the more scientific term now is context engineering, where you craft a prompt, and depending on how good that prompt is, and especially how good the context is, the model will be able to give quite powerful responses. So a prompt is a guiding question with a relevant context, which shapes the response. It turns out this can be quite powerful in the sense that people have demonstrated that you can also do things like diagnosing patients with LLMs. So in this case, you can say, you are a helpful medical assistant, you will be provided and asked about a complicated clinical case, read it and provide a diverse differential diagnostics. And the paper demonstrates that given the relevant context, the LLM can be quite good at choosing the relevant diagnostic for a case. So given this and many other proofs, are LLMs all we need now? Well, even the art of prompting itself is very brittle. So alongside all of the results showing how well LLMs work, given the proper context, there are a plethora of other works that show, for example, how brittle prompting is. So in this paper from last year, actually, the University of Zurich, they demonstrated that LLMs are more likely to comply with disinformation requests when prompted using polite language. So if you say please, maybe the LLM will do something else than it was supposed to do. For example, it will be more likely to give you disinformation instead of information. So this is not the only problem. Of course, there is a very big issue in the biases that stem from the training data. LLMs are trained on large corpuses of text. They will inherit whatever bias is present in that corpus of text. And if you don't pay attention to the source, this will be propagated and enhanced. So this is a little bit of a play of words, attention to biases, because it also refers to the mechanism of attention in LLMs. I don't go into details, but attention is what helps large language models to understand words in context. So this snippet from a paper gives a relatively good, simple example. It has the sentence, the girl and the boy walked home, she. And you can see here visually the attention mechanism points to the fact that the LLM links the word she in this sentence to the previous word girl. So the model somehow through this mechanism learned that she refers to the word girl in the previous sentence. Now, if you study this in a different setup, and the paper was quite clever in doing this, you can start to see biases encoded in the model. So for example, here you see the doctor asked the nurse a question. She, and now if you look at the attention mechanism, you can see that in this context, she is linked to the nurse in the previous sentence. Whereas if you would continue with he, it would be related by the LLM to the word doctor. So this has been used to analyze biases and to understand the fact that probably this model is encoding some sort of gender bias based on the text that it has seen and it has been trained on. So this is another problem that all large language models are prone to. And this is why controlling the source information is, of course, very important when you want to provide answers via LLMs. Now, if we want to go through a non-exhaustive list of other limitations, hallucinations are well known by now. They are mitigated through different mechanisms, especially in the public services like ChatGPT, where there are a lot of now hooks, and I will show one of them, which prevent models from giving answers when they should not because they don't know it. But it remains a problem. Cutoff date is a big problem. So because large language models are expensive to train, they are only trained again periodically. So the large language models that you might be using today might only have encoded knowledge up until perhaps this time last year. So whatever happens after that, of course, can be retrieved through some classical search, for example, on the web, but it will not be part of the knowledge encoded by the large language model itself. It is very costly to train LLMs. There are environmental considerations attached to this because it is costly in terms of energy consumption, obviously. If you don't speak about public data, but rather private data, there are, again, other concerns. So sensitive information, of course, should not be put in public services such as ChatGPT. You don't really know why an answer was produced, and you don't really know where an answer is coming from. And because of this, you cannot really credit the initial authors of that answer. So it is clear that there are quite a few disadvantages. These are known and have been known probably now for quite some time. But in this context, we can see the role of digital libraries, digital repositories, and especially curated digital repositories as very important. And if I can summarize this in a very brief form, I would say the role is to provide facts, not words. So LLMs work on words and more specifically on tokens, so not even words, whereas digital repositories, curated digital repositories, work with facts or strive to work with facts to the extent where curation can keep the pace of extracting facts from recent literature and so on. So facts, not words. And I think this is extremely important. Therefore, I think that data repositories provide a foundation for trustworthy AI. And this, I think, is already recognized also by the commercial players. So today, if you do in ChatGPT a search like what are the Go annotations, this is a specific ontology term that describes functions of proteins. It's a very typical thing that you would search for a protein. What ChatGPT tells you is accurate and correct, but that is not because of the underlying model, but because the answer has been retrieved from curated sources like UniProt. If these sources were not available, and in ChatGPT in particular, you can disable searching the web, then the answer that you get is very conservative. The model now tells you, I don't know, check directly on the website, which I think is a fair answer to give. Therefore, LLMs are certainly very powerful, but especially when they are augmented. First of all, with facts. So here is again the role of digital repositories, curated databases, which can serve as the context, the relevant context, the ground truth that an LLM can use, but also augmented with tools. So one of the tools that you have seen in the previous case of ChatGPT is going to search the web. There are other tools, for example, anything that a database offers via an API, this can be exposed to LLMs via the so-called Model Context Protocol, which is a standardized way to describe APIs, so services that are already provided by different service providers, including, for example, existing repositories. And when an action needs to be performed, a user can describe it in natural language, and an LLM, based on what descriptions of services are available, can decide which one to invoke and execute. And if we look at this picture, I think it is clear that digital repositories, digital libraries can provide both the context, the facts that an LLM can use in a retrieval augmented manner, and the tools that can complement just the existing facts. For example, a tool could be a search API over an existing digital library and so on. The way that this is done, and we have examples that we have developed with the Swiss Institute of Bioinformatics, is, for example, for enabling retrieval of facts, you can index the context of the repository, and I will go into a little bit more details in the next slides. Whereas in the case of tools, you can obviously expose things that can be provided as services on top of the existing database via an API, and then just describe them in a natural language fashion so that they can be used in the proper setting. So this probably is already also known by now. Retrieval augmented generation is a means to retrieve the relevant context when a user asks a question. And how can this be implemented in the case of digital repositories? Well, first, you would need to identify which information should be searchable via an LLM. Typically, this is, for example, metadata of the different records. Once you have identified this, you can embed them. And by now, doing this has been commoditized. It's very easy to use existing services to do this. In, for example, a vector database like OpenSearch. And whenever a user asks a new question, you just look for the relevant information, so the most similar information to the question in this vector database. Why? Because you want to augment the prompt with this retrieved relevant context in order to generate accurate answers. So this is the retrieval augmented generation paradigm. In complement to this, for additional analytics or for data that you update frequently, which you don't necessarily want to re-index all the time, you can use MCP, so this model context protocol, a description of a service. So you describe APIs that you expose. This means you document what they do in natural language, so it's fairly straightforward. There is a certain format that you have to adhere to, but it is relatively simple to understand. And for each user question, the LLM will try to figure out what is the relevant tool to invoke in this context, and it will invoke the tool, and this will be executed behind the scenes, and the LLM will then present the results to the user. For a real-world example, I will mention the case of the European Open Science Cloud Data Commons. So this is a platform that is currently being developed as part of a project, an EOSC Infra project, to enable both interdisciplinary and cross-disciplinary data discovery across the EOSC Federation. So the goal is to enable researchers to discover data that already exists in the different repositories and potentially combine it with tools that can be used in conjunction with this data. The goal is to establish a trusted ecosystem. So this goes again to the idea of trusted repositories as a solid foundation for research. So it aims to be sort of a one-stop shop for dataset and tools search across the European research landscape. And it is a fairly large project with 12 use cases across diverse disciplines. There are many partners across Europe in this project, and SIB is also one of them. And the University of Zurich, ETH, Switch has also an important role, but it is really a very large project. CERN is also represented there as a use case. And at a very high level, the way that this is designed is that on the one hand, you have the different data repositories that provide APIs through which, for example, they expose metadata, where the matchmaker, so this is the part that looks at the data part of the European Open Science Cloud landscape, provides a user interface where users can just search for data that they're interested in. So, for example, this can be give me climate-related data for the past 5 years. So the matchmaker will provide relevant data sets from the repositories that were indexed, and also tools that can be used with those data sets. And this is the part of the data player. I will refer more to the matchmaker, where the SIB has a larger involvement as well. So this is a platform that aims to provide AI-based discovery of data. So it aims to enhance the findability of data in order to facilitate knowledge discovery. There is already a proof of concept that exists. You can find it online. And you will see there what are the repositories that have been already indexed. And you can search for data sets from those repositories, and you will have a ranked list of data sets in response to the question that you asked. You will see the original source and a relevance assessment. So how similar or how relevant is that specific entry to your initial search. It is a proof of concept because the project is still relatively new and ongoing. But I think it's an important step in trying to demonstrate, also because this is all in the public space and open source, how you can build a platform that leverages repository metadata in order to more easily make the data discoverable by researchers across domains. I have mentioned this more or less, so I think, yeah, I can probably move to sort of the next part. So I come from the knowledge representation unit at the SIP. So I just want to address what is knowledge representation. And I think this is a nice quote that summarizes it. So in essence, knowledge representation serves as the language through which we communicate with AI systems, both in providing them with the information they need to reason or make predictions and in interpreting the results they produce. And what I would like to think of when I talk about knowledge representation is disambiguating and making explicit all the things that you don't want to leave to chance. So of course, LLMs are relatively good now in making connections and aligning things that are similar, but probably not the same. But there are some things that you want to make sure you don't leave to chance. And these you can make explicit via knowledge representation. I will show how this is done in the case of bioinformatics. But first, just to mention why this is important. So for this, I will go into a few seconds history of bioinformatics databases. So it used to be the case that different databases were developed by different research groups, and even when they would speak about the same things, they would use different identifiers. Now, of course, this makes it very hard to do any sort of correlations or to bring together these data, and it is rather a development in silos. Now, to illustrate why and how bad this was, there is a now famous quote by Michael Ashburner, who initiated one of the important ontologies in the field, who said a biologist would rather share their toothbrush than their gene name. So there was a realization that the situation is bad and should not continue in this way if we want to be able to put data in context. I think this is more relevant than ever today. And fortunately, in bioinformatics, things have improved a lot. So we have gone from the more siloed approach to a world of interconnected databases where there is good agreement on many things, for example, some of the standardized identifiers. And this is what allows you to make connections and correlations across the different sources. And this is now crystallized in the FAIR data principles, which I think are fairly well known by everyone by now, but they stem from the bioinformatics community. And this year is the 10th year anniversary of the FAIR data principles, which I think is interesting. So just to emphasize again, this is what allows us to go from silos to interconnected knowledge. And because the final goal is to make use of this interconnected knowledge, I think it is important to understand the role of also knowledge representation and agreeing on things that should be standardized across different resources. One way to build this web of different entities connected together in a very easy way is through knowledge graphs. So in our unit, we work a lot with knowledge graphs. I will not go into details, but just to say that this is a data model, which is composed mainly of triples, where a triple is a subject, a predicate, and an object. For example, Bob is interested in the Mona Lisa. And the reason why this is interesting is because if I have a knowledge graph and you have a knowledge graph and they share some identifiers, for example, we can put the two together and the result is a larger knowledge graph that we can use to extract more insights. They have a long-standing history in bioinformatics. So actually the term knowledge graph was coined by Google because marketing. They introduced this term in 2012, but actually UniProt had already been around in this format since quite a few years. And today it is the largest publicly available knowledge graph. So still very relevant and important. It is used whenever people want to test scalability of the different technologies that use knowledge graphs. So that's, I think, speaks to the importance of it. But apart from UniProt, the Institute curates quite a number of knowledge graphs. And of course, there are others in the public space. For example, Wikidata is a knowledge graph equivalent almost of Wikipedia. And the reason why this is important is because it provides us a way to ask questions that span across the different data sets if they are interoperable. In the case of bioinformatics, you could ask things like, what are the human genes involved in a type of cancer that have an equivalent expressed in a model organism where you can study them? And the way that this is done is through a relatively complex technical query. I will certainly not go into the details of it, but just to say that it is possible, but it requires a lot of technical expertise. And this is why large language models, which are a very good interface to data, provided us a very good opportunity to go from questions to queries automatically. So they solve an important need to generate these kinds of complex queries. And this is what has driven the development of ExpasyGPT, which is a service developed within the Knowledge Representation Unit at SIB in collaboration with the SIB Biodata Resource Team, which is an AI-driven tool that generates queries in response to user questions. So you can ask general questions like what resources are supported by the tool, but you can also interact to start asking specific questions like what are the functions of certain proteins, or questions like the one that I've mentioned earlier. And you can try it out. It is a public service. It's also open source. So if you have a knowledge graph that you would like to make more easily accessible, you can use this service. It's relatively easy. I will not go again in the details of what happens behind the scenes, but just to say that the main sources of information that the LLM uses in generating queries are the metadata from the knowledge graphs that are indexed. And this means human readable labels, descriptions, but also examples. So LLMs are very good at learning from examples. Of course, they have also been trained on a lot of examples from everywhere online, but just to sort of adapt it to the use cases that you have, you can show it examples of how queries look like for your knowledge graph, and it turns out that they work very well. Of course, we also have a validation step because hallucinations still happen. but a lot of them we can catch through a post-processing of the answers that the LLM generates. So there are a number of resources that you can look at, and I will also share the slides afterwards so you can do this more easily. Now, heading towards the future, I've only shown some relatively simple examples, but some of our collaborators, for example, are looking at going towards autonomous scientific research. So there are, in the research of the future technologies or the future applications of generative AI, there are very interesting developments, including how you can create different agents that perform the tasks that you, the researcher, would typically do, including literature review and research, including automating tasks, and so on. And to some extent, and especially if you can evaluate the outputs and you can benchmark this, this can potentially impact all the activities that you are performing. So it is quite interesting to see the developments that are happening across the board. Now, there are still a lot of challenges that emerge from these developments. One is AI upskilling, if you will. So it is a rapidly changing environment. I think it's very hard to stay on top of things. You cannot always have an AI expert in the team. Sometimes you cannot have an AI expert even in the larger department or organization, and this is a big challenge. You also need to have, to some extent, the right resources, the right infrastructure, particularly if you're dealing with sensitive or non-open data. And you need to build benchmarks because these are, or to identify benchmarks that apply to your use cases, because these are the only way that you can make informed choices in a world that is very fast-paced. So you always need to refer back to this good old saying, trust but verify. So benchmark the things that you are trying to prototype. So for a few conclusions, I think generative AI can be an important enhancer for data repositories, for digital libraries, and for assisting in all the steps along the way. I have not mentioned about GenAI for curation, but I have a few pointers at the end about this specifically. And there are teams that are doing a lot of interesting work in this space as well. Benchmarking is extremely important. So, for example, we have participated recently in a challenge that is sort of striving to do an automated benchmark of the task of translating questions to queries, and we have obtained good results there, which is encouraging to sort of have an external assessment of what we develop as well. And finally, most importantly, the role and importance of public repositories continues to grow. And I think upskilling and infrastructure need to somehow keep pace. But I think if we emphasize this growing importance in all of the spaces that we can, showing also examples from the commercial players that are relying on this infrastructure, I think this is a very important thing. So I have put some references. I think all of the presentations by Chris Mongol from UC Berkeley are extremely good for the GenAI for curation, if you're interested in that specific part. In preparation for this talk, I've also looked at the past talks of this series, and I think they are worth also having a look. In particular, AI for digital libraries was very good in going into a little bit more technical depth. And we periodically have training courses. So, for example, at the end of this month, we will have one about specifically AI for biodata exploration. So maybe in the future something will be relevant also to the things that you would be interested in. And that's kind of all that I wanted to mention. Thank you for your attention, and I would be happy to answer your questions in the following.
Thank you. Thank you so much, Ana Claudia, for this interesting presentation. As you said, now we open the floor for questions. So please feel free to write on the chat or just open your micro and start the discussion. In the meantime, I have one question for you. So we give some time to the attendant. So you mentioned that there are a lot of challenges there for the use of generative AI. But what do you think would be like the most important aspect to improve the AI systems so that it can be really implemented with research?
I think the challenges I mentioned go in conjunction. So one, I think upskilling is really important, and I think across the board, even in the industry, there is a lot of effort going into simply pointing to the relevant tools, because sometimes the relevant tools are already there, but we don't know about them, or we don't know which one to choose. And this would already be quite good. So just changing the mindset in trying out more things. Benchmarking is important. So things that, for example, in semantic search, the things that we do, whenever there is a new model, we have to see whether it actually works better than the previous one or not. And we have sometimes noticed that the newer model is worse than the previous one. And if you don't have something that you can quickly test out and see for your specific use case, you might actually make things worse simply because you didn't have the means to test them. And of course, we are privileged if we can only work with open data, because then you can just use public services. Things are a bit easier. One of the big problems is when you have non-public data, because then you need to have a local deployment of an LLM. If it is a small model, it might perform worse. So you might have to do more engineering in order to make it work better. So it's always a trade-off of where you invest more resources. The bigger models probably will give you for most tasks a better performance, but they cost more. So yeah.
Thank you. Thank you so much. No, indeed, it's very interesting. And also what you said, no newer models they are built to be better than the others, then they become worse even.
Sometimes they do, yes.
Mm-hmm. Everyone is very quiet. Probably they are impressed about all the information you give us. Okay, so on another note, I have another question also regarding like how in the scientific communities they are using AI now. So how do you think this will change the research workflows and also like the way of publishing in the future?
Well, I think it has already changed all of these to a very large extent, probably more than we realize. And to be honest, I think it is a little bit of a pivotal moment where we will have to reassess a little bit what is the most valuable part, for example, of a paper. It used to be very important to have good writing, a good structure, and so on. All of these have become commoditized. But now we see other things becoming commoditized, like the literature surveys. Right? Now you can use tools that can do this for you. It is a risk to rely too much on this, but on the other hand, our time is also limited. So I think that more and more, as we have seen with the boom of public information being available, more and more the value will be in being able to filter from our side, for example, filter what are the actual useful tools, what are the things that help us save time rather than waste time. And I think a reassessment of the research landscape will happen because now we are seeing an influx of papers, of proposals. I've seen recently there's been uh, big problems even in reviewing, for example, proposals. And I'm sure that the ease with which you generate such a written proposal now compared to previously is one of the guilty factors in this. So I think we are already in a transformative period with both good and bad implications. Yeah. So we want to save time, but we don't want to reduce, the human
Quality.
intelligence,
Yeah.
so to speak. So yeah.
Yeah, not only the effort, also the quality of
Yes.
what is
Yeah.
there. Yeah. Thank you.
May I jump in and ask a question? Can you hear me okay?
Sure. Yeah.
First of all, thank you for the talk. This is really timely for us and very interesting. I have a question around interoperability and enabling search across multiple repositories with knowledge graphs. Can you perhaps speak a little bit to what it takes behind the scenes to enable that?
Yes. So, well, at the very minimum, you have to have at least common identifiers across. So when you have, for example, the types of things that we work with are proteins, genes, and things like this, and these have identifiers which are standardized. And what this means is that you will find them in exactly the same way across the different data sets, and then they can be used to make intersections between the data sets. So the basis of interoperability, and this is where the F from FAIR and the I kind of converge, is in identifiers. That's the first step. Then, in order to actually have this more knowledge graph structure, it's relatively easy. For example, if you have a tabular database or a relational database, as they are called, to transform these into a knowledge graph format. If you already use also some standard ontologies in your domain, this is also very useful because it allows you to align different data sets beyond just the identifiers. So that's already better than that would be the next level. And all of these are usually driven by the use cases. So if you have concrete use cases where you would see the benefit of interoperating different databases, then you can start by just making a semantic representation of at least the parts that are necessary to address those use cases. So you can do this a little bit incrementally. I hope this answers the question.
It does, yes. Thank you.
So we have a couple of questions now on the chat. I don't know if you have the chance to, maybe we can read them out loud. So we have one from Melissa saying that, first of all, thank you very much for the presentation. And then that you mentioned the gender stereotypes perpetuated by AI. So using the example of the word nurse being associated with she. And well, they have a curiosity now to know how this can be countered.
Yeah, so this is a very good question, and there are research teams that deal with this specifically, and they are both in academia and in the industry, because this is a big problem for the industry as well. I think there are two steps. You know, the first step in fixing any problem is to admit you have a problem. So this is detecting that there are such biases in the model or in the training data. And so I think a lot of the work of the teams that I mentioned are going in the direction of detecting biases in the models. Now, once you have detected these biases, I think the next step is to try to go back to the data sources and see how you can balance them in a way that the types of examples that represent, if you have two categories, the type of examples that represent category 1 and 2 are balanced as opposed to biased towards one or the other. But it's not an easy task. But I'm sure that there are a lot of efforts invested in this, because yeah, it can very easily become a problem. Yeah. So I see a second question. So libraries provide scientific information. How do they need to evolve? Do you think they need to propose MCP? Yes, I think so, because MCP is a low effort adaptation of an API. So compared to the effort of building an API on top of a repository, the effort of building an MCP server on top of an existing API is low. So you essentially have to take the existing API calls and document them, describe them such that, you know, the way you would describe them to a human colleague. So if you want to describe to someone what does this API do, it's essentially more or less the same, but in writing with an MCP server. And with this, there are many benefits. So for example, at the Institute, we have seen that now different AI agents that you can use online refer to the MCP of ExpasyGPT, for example, because they have discovered it online. And so it's also a way to increase visibility of the repository, because it's now accessible also through the different LLMs, and then probably you will get more users just because of this. So I think it's worth the extra investment. Yeah.
Thank you so much, Anna. So we will give last minute, because we are close to the limit of time, to see if someone else come up with another interesting question. If not, in the meantime, I will share my screen for a second. So to inform the participants of this talk that at the middle of May, so the 19th of May, we will have another library science talk. In case if you would like to attend and join us, we will have with us Natalia Lash, Stephen Fletcher, and Juan Alonso Fernandez, talking about archives, preservation of images, and so on. And just to let you know that we will have this. We have something on the chat. So we have another question from Simon. How do you better curate all of the latest advancements and news?
This is a very good question, and I think I don't have a definitive answer to this. My experience also with my colleagues, who are oftentimes better than me at keeping pace with the different things, is sometimes it also takes a little bit of hands-on trying of things. So I think you can see the different tools that are being advertised. For example, once they become a little bit more popular, it is a matter of trying them out for yourself to see if they work for your use case. And I think the best way is to set aside probably a very specific range of time for this, because you could also go down a rabbit hole where you lose half a day each day for this, for keeping up with things. But I would say, yeah, maybe also wait until some things stand the test of time. So don't always jump in the latest and greatest, but try things out on your own as well. Yeah.
Thank you so much.
Thank you.
I'll stop sharing now. And well, thank you once again for accepting the invitation to this library science talk. It has been a pleasure. We will, once the record is finished, upload it on our YouTube channel so you can share it with the community. We will do as well with our A-list community. And yeah, thank you so much.
Thank you very much. Thank you, and have a good day. Bye.
You too. Bye.